All right, so how's everybody doing? Today we're going to start Chapter 7, Section 1, which is the greatest common factor, and then we're going to transition into factor by grouping. Now, everything that we're going to be doing in Chapter 7 is actually the exact opposite process that we learned in Chapter 6. So, let me start off with probably one of the most basic examples, which is our distributive property. So if you recall, the distributive property, and I'm not going to write down the technical definition, we're just going to go with A times B plus C equals, now we know with the distributive property, if you have a number in front of a quantity, what you're allowed to do is distribute that number in front of the quantity. In other words, A times the quantity B plus C is nothing more than just A times B plus A times C, okay? So to be honest with you, this is what we learned in Chapter 6. This is everything we did in Chapter 6 was we wanted to remove parentheses, we wanted to group like terms, and we wanted to simplify expressions, or we had like complicated polynomials and stuff like that, but basically we were distributing, removing parentheses, combining like terms, and then going from there. In Chapter 7, and I'm going to write this in red, in Chapter 7, here's what we're going to do. What we're doing in Chapter 7 is we're going to start with A times B plus A times C, and our goal is to get back to the original expression, which is going to be A times the quantity of B plus C. So if you think about this, if I go from left to right, I multiply. And if you're thinking about going the opposite way, well, what's the opposite of multiplication? Well, that's going to be division. So what we're looking for now is what we call a greatest common factor, or an abbreviation of that would be just the GCF, okay? So what I'm going to do is I'm going to show you how to do this with just numbers first. Keep it simple. Then I'm going to show you with variables, which I think is honestly the easier of the two. And then we're going to look at factoring out a greatest common factor in a polynomial expression, okay? So the first thing, like I said, I want to go over is I just want to find the greatest common factor, so the GCF, for 27 and 18, okay? Now, the process on which we do this, you already know, which is fantastic. So we're going to use good old prime factorization. Boy, if you haven't learned anything in this class about me, hopefully you've learned that I love prime factorization. So what I'm going to do is I'm going to break down 27. So that's going to be 3 times 3 times 3. And then 18 is going to be 2 times 3 times 3. Okay? And the goal with finding the GCF is a little bit different than the LCM. Remember, with the LCM, we would just draw arrows straight down. In fact, let me just copy and paste this because I want to show you the difference here, okay? So you gotta love technology. I can copy and paste this real quick. There we go. So remember, with a lowest common multiple, the LCM, we would draw these arrows straight down, and then we would say, well, the LCM is going to be the multiplication of all those. So in this case, it's going to be, 27 times 2. The LCM is going to equal 54. With the greatest common factor, we're not concerned with all the numbers. We're concerned with numbers that overlap. For example, for the GCF for 27 and 18, when I write out the prime factorization, notice that the only overlap that I have are the 3's. So my GCF is going to be 3 times 3, or my greatest common factor equals 9. Now, earlier in this lecture, I'm going to scroll up, I said we are looking at division as our goal. So if you think about this, 27 divided by 9 equals 3. And 18 divided by 9 equals 2. And why am I showing you this? Well, the reason why I'm showing you this is because 9 is the largest number. It's the greatest number that I can divide 27 and 18 by and still get whole number answers. In other words, no fractions, no remainders, no decimals. We get whole numbers. And that is the key to this, okay? Let me put a little exclamation point there because I'm very excited. So let me show you how to do another one here, okay? I think it's always good to show more. So find the GCF for 48 and 80. Now, once again, we're going to use our prime factorization technique. So 48, and I'm just going to break this down real quick. I know 48 is going to be 4 times 12. I can break this down into 2 times 2. I can break this down into 2 times 6 and 2 times 3. So off to the right, I'm going to write 48 equals 3 4s. Did I say 3 4s? What am I even talking about? 4 2s. Holy cow. I would edit that in the what we call a post, but I'm not doing it. So we have 48 equals 2 times 2 times 2 times 2 times 3. So 4 2s and 1 3. Perfect. Now we're going to do 80. So 80 is going to be 8 times 10. 8, hopefully we know that by now, is just 2 times 2 times 2. 10 is 2 times 5. So 80 is going to equal, and I need to be very careful about how I write this, all right? Just like the LCM, I want to make spaces where I can. So this is going to be 2 times 2 times 2 times 2. And then times 5. I'm going to write the times 5 all the way to the right. And remember, all we're concerned with here are numbers that overlap. That's why organization is so crucial in this. So here are the numbers that overlap. And that's it. So our GCF is going to equal 2 times 2 times 2 times 2, or the GCF equals 16. Okay? Now, if you wanted to, you can apply the same technique to variables. So find the GCF for x to the third and x to the fifth. Okay? Now notice here, there's no prime factorization that we can do, and that's okay. Write it out. X to the third equals x times x times x. X to the fifth equals x times x times x times x times x. Therefore, my GCF is going to be the overlap, which is nothing more than just x times x times x, or x to the third power. That's the GCF, x to the third power. Now, I'm going to try to write as clean and as neat as possible here because I'm going to show you something, okay? And hopefully you see it. So we're going to find the GCF here for y to the second and y to the, we'll go 6, okay? So y to the second equals y times y. I can zoom out here a little bit because I want to keep the previous problem on the screen. Y to the sixth is going to equal y times y times y times y times y times y. Once again, our GCF is going to equal the overlap here. So we're looking for the overlap. Beautiful. It's right there. And that is nothing more than just y times y, or y to the second. And in red, here is the thing that kind of is going to make our lives so much easier. Let me write it like this. When you encounter variables with exponents, the GCF will always be the variable with the smallest exponent. So what am I even talking about? Well, I'm going to use green now. Notice in the first problem, find the GCF for x to the third and x to the fifth. Boom. That's smaller. It has, the degree is smaller. It's 3 compared to 5. Notice, what was your GCF? Your GCF was x to the third. Look at the second example. Boom. The GCF for y to the second and y to the sixth. Well, y to the second is smaller. Notice what my GCF turned out to be. So if you know this little, and it's not, this is not a trick. This is not, this is one of those things where it's, if you fully understand what's happening, you will see this over and over again. When you encounter variables with exponents, the GCF will always be the variable with the smallest exponent. So now what I'm going to do is I'm going to marry these two. And what do I mean by that? Well, here we go. This is what I'm talking about. Let's find the GCF for 12x squared, comma, 18x to the third. So notice here I have numbers and variables, but it's easy because, and I'm going to write this in blue. Let's get a really pretty blue here. How about that one? I think that one's going to work. All right? Because here's what it's all about. The GCF will always be the product of the following. First, the GCF of the coefficients, which are the numbers in front of the variable. And then 2, the GCF of the variables. So this is one of those things where you have to know what these words mean. Remember, mathematicians, at least the ones I've encountered, we hate writing things. We hate writing letters and stuff like that. Now, I know it's counterintuitive because variables. What I'm saying is sentences, stuff like that, I don't like writing them. In other words, I write precisely what I mean. And what I mean for the GCF will always be the product. It's always going to be the multiplication. It's always going to be the multiplication of the following. You can find the GCF of the coefficients. You can find the GCF of the variables and just write them as they're all being multiplied. So let me show you how this works. Man, this is so much fun. You have no idea. All right, 12. Well, that's going to be 2 times 2 times 3. 18 equals 2 times 3 times 3. Notice the organization that I have here. That is key to this. If you're not writing in spaces and spacing things out and writing organized, I'm telling you, this is going to be so difficult. Now, our GCF, remember, we are only looking for overlap. So I got an overlap there, and I got an overlap there. So my GCF for the coefficients will be 2 times 3 or 6. So I'll put a little block around that. Now, let's do the variables. Well, if we look at the variables, x to the second, comma, x to the third, we already know from the previous example that the variable with the smallest exponent is going to be the GCF for the variables. Put a little box around that. Now, according to this definition in blue, if I just write these two GCFs being multiplied, and notice I'm writing it large because I'm making a point, there's your GCF, 6x to the second power. That's a beautiful thing when you think about it. And how simple this was. It's all about just keeping things organized and writing out neatly and understanding just what we're trying to do. Okay? Let me do another one here. We'll get a little bit more complex. All right, so find the GCF for 6ab to the fourth, comma, 8a to the second b. Okay? So, like I said, keep it simple. First thing, let's do the coefficients. So we have 6, which is 2 times 3. We have 8. And you know what? I need to put a little space here. 8 is going to be 2 times 2 times 2. Now remember, GCF, we are looking for overlap. So that's right here. This is it. Our greatest common factor in this situation, come on, work with me. Work with me. There we go, is a 2. So that is only for the coefficients, okay? Now let's do the variables. So the variables in the first, and I'm going to write them out again, AB to the 4th, comma, A to the 2nd B. Now, we have 2 variables, but that's okay, because the rule says it's the smallest exponent for each of the variables. So I'll highlight first. Let's look at the A's. This is A to the 1st, and then you have A to the 2nd. Well, A to the 1st is smaller. Now we're going to look at the B's. In the first, you have B to the 4th, but in the second, you have B to the 1st. So that is going to be smaller. Therefore, your GCF for the variables looks horrible. There we go. Fix it. It's just AB. Because remember, this is A to the 1st, and when you compare it to A to the 2nd, that's smaller. And this is B to the 1st, but when you compare that to B to the 4th, it's smaller. So now the GCF just overall, I guess I'll put like an overall here, is going to be 2AB. That's exactly what we're looking for. Okay? So now that we kind of have an idea on how to find GCFs, we're going to move into the main topic of discussion today, or one of them at least, is factoring the GCF, or the greatest common factor, for a polynomial. Okay? So what I'm going to do is I'm going to give you a polynomial, such as 2x plus 16. Okay? Now, remember at the very beginning of class, you know what? Let me just scroll up. There we go. So what I'm focusing on here, and I'm going to highlight it for so you know where I'm looking at, is right here. I'm going to zoom in. We're starting with a problem that looks like this on the right-hand side. I just highlighted it in green. Our goal is to transition back to this. Now, I don't know if you know what you're looking at right here, but I'm going to tell you what you're looking at. This right here is the product. In other words, those two things are being multiplied. It's multiplication. So I'm giving you the answer. It's kind of like playing Jeopardy. I'm giving you the answer. What I want you to do is give me the question. Okay? I'm giving you the answer. What I want you to do is tell me what the question was. So let me show you how this works. So we're going to scroll all the way back down to our problem here. Boy, I already wrote a lot. All right, so here we go. We want to factor... Oh, geez. Don't you hate when that happens? So we want to factor the GCF for this polynomial. Here's our example. 2x plus 16. So the first thing I'm going to do is I'm going to ask myself, and it's always 2 steps. So factoring out... Let me write it off to the right-hand side. Factoring out the GCF. You always want to ask yourself 2 questions. Number 1, what's the GCF for the coefficients? And then number 2, what's the GCF for the variables? Now, you might have one or the other or both. You don't know. Every problem's different. But these are the questions you ask yourself. First, GCF for the coefficients. Well, if I look at the coefficients, I have a 2 and I have a 16. So, off to the right-hand side, 2 is prime. So I write 2 again. 16 is 2 times 2 times 2 times 2. Remember, we're only looking at the overlap, which is right here. So I know there's a coefficient, or there's a GCF for the coefficients. It's a 2. So I know, so far my GCF is a 2. The question now becomes, is there a GCF for the variables? Well, in order for there to be a GCF for the variables, and this also applies for coefficients, you got to have things in common. For example, in that first term, I have the letter X, which is great. But in the second term, there's no X. And that makes me sad because that means there's no GCF for the variables. So, all right, no GCF for the variables. Okay? Now, here's what we know. And I'm going to highlight this in blue. Our GCF for this polynomial is 2, which means I'm going to factor that out. Now, when you hear the word factor, you should be thinking of prime factorization, meaning numbers that are being multiplied. Okay? So notice here, by me factoring out a 2, these are being multiplied, which is great. That's what I wanted to do. The question becomes, what goes inside these parentheses? Well, all the way at the very beginning of class, I told you that factoring something out, and I'm going to scroll up, this is the last time I'm going to scroll up. And I'm going to zoom in and I'm going to circle. Right there. Anytime you factor something, it's all about division. Therefore, when I go all the way back down to my problem, when you tell me that the GCF is 2, what you're really telling me is that you can divide all these terms by the number 2. And when you do that, watch what happens. 2x divided by 2 is going to be x because the 2's reduce. Then you have a plus sign, so copy it down. And then 16 divided by 2 is 8. And right there, you've just successfully factored your first polynomial. Now, there's an easy way to check yourself. All you have to do is multiply. Just distribute. You got to get the same answer. 2 times x is 2x. 2 times positive 8 is positive 16. And that's what we're going to be doing for every single problem. Now, there's a bunch of different factoring techniques that we have, all right? We have greatest common factor. We have factor by grouping. We have difference of squares. We have difference of cubes. We have sum of cubes. We have all these different ones that I'm going to teach you. And I have a nice little flow chart that I'm going to show you. But it all starts with the GCF. So this is always going to be your first step. I don't want to use the number 1. Let's use the letter A. You're always going to ask yourself, is there a GCF? And if so, factor it out. So now, I'm just going to do a bunch of problems. So here's our next example. Let's do 6a plus 24. Well, let me write the directions. How about I'll just write factor the following. All right, so part A. 6, we'll use x now. 6x plus 24. Well, remember, what we're looking for, is there a GCF for the coefficients? The answer is yes. Now, I'm going to speed up here a little bit, okay? If you need to, pause the video, find your own GCF, and then make sure it's the same as what I got. But the GCF here is going to be a 6. When I look at the variables, the first term has an x, which is great, but the second term does not have an x. Therefore, I cannot factor an x out. Remember, both terms have to have a common factor. So, since the only GCF here is going to be 6, then what's left over on the inside is going to be x plus 4. And if you're wondering where I got the x plus 4 from, look on the right-hand side of your screen. As soon as you've established that 6, and I'm going to point to it, as soon as you establish that's your GCF, what you're really telling me is you're dividing every single term by the number 6. In the first term, the 6 is reduced, you're left with an x. In the second term, 24 divided by 6 is 4. That is where the x plus 4 came from. Okay? Let's try another one here. How about 5x minus 25? Well, here your GCF is going to be a 5. And then what's ever left over on the inside is going to be x minus 5. Now, how did I get that? Remember, once you establish 5 is your GCF, You're going to divide everything by 5. 5x over 5 is just going to be x. Drop down your minus sign. 25 divided by 5 is 5. That's how I got x minus 5 on the inside of the parentheses. If you need to, you can always check yourself by distributing. So 5 times the quantity of x minus 5, if I distribute, I get 5x minus 25, which is exactly what the original problem was. All right, so now we're gonna step it up here a little bit, okay? Please do not make this mistake. If you understand the process that we're using, you'll never ever make this mistake. So we're gonna factor 14x plus 14. Once again, we need to find that GCF for the numbers first. In this case, it's going to be 14. For the variable, no GCF, and that's okay. Now, you're left over with x plus 1 inside the parentheses. So pause the video, make sure you understand why, and then unpause it so you can see why. So here I'm going to unpause it. Well, actually, you unpaused it. Once you established 14 is your GCF, what you're telling me is you're dividing every term by 14. So these reduce. You're going to be left over with an x. And then over here on the right-hand side, note that you have 14 over 14, which is a fraction. It's n over n. And we know when the number in the numerator and the denominator is the same exact number, other than 0, it's a 1. So that's how I got 14 times the quantity x plus 1. So please do not make that mistake. All right? So now what we're going to do is we're going to step it up here a little bit. Okay? We're going to step it up a little bit. So let's look at this example. We're going to factor 5x to the third minus 25x squared. All right? Now we stepped it up. So for our GCF, I already know a 5 exists and x squared. Now, if you're sitting there going, whoa, wait a minute. How did you get that so quickly? Here's what I did. Number 1, GCF for the coefficients. So 5 equals 5. 25 equals 5 times 5. Remember, GCF, you're looking for overlap. The overlap are the 5s. Okay? So there's my GCF for the coefficients. Step 2, GCF for the variables. Now, I'm going to highlight, but then I'm going to erase. Notice in both terms, you have x's. You got x's in both terms, which means you're going to be factoring out x's. But now the question becomes, well, how many? Well, if you recall, the smallest exponent is going to be your GCF. So the GCF for the variables is x to the second. So now I'm underlining on the left-hand side of the screen. That's how I got the GCF, 5x to the second. And once you get really good at this, these steps that I'm writing out, step 1 and 2 on the right side of your screen, they kind of go away because you start to see things. If you don't, hey, that's fine. Write it out. My thing is, I always want to provide you with at least the tools to be able to do the problem. If you could do it in your head, that's great. If you can't, I don't care. All I care about, you understanding, getting the correct answer, and then being able to apply it to another problem. All right? So, pause the video, write down what you think goes inside the parentheses. All right, good. So, what you should have got inside the parentheses is x minus 5. Now, if you didn't get that, let me show you why we get the x minus 5. So, I'm just going to draw a little box underneath the problem. This is going to be my work. Okay? So here's the original problem, 5x to the third minus 25x to the second. And what you said was the GCF is going to be 5x to the second. Therefore, what you're telling me, and I'm going to write this all the way down at the bottom. So what you're telling me is you're dividing every single term by 5x to the second. And notice by doing that and simplifying, look what you get. In the first term, the 5's reduce. They turn into a 1 over 1 or just a 1. And then x to the third divided by x to the second is x to the first or just the letter x. Now, you have a minus sign, so copy it down. Now for the second term, 25 divided by 5 is going to be 5. And then x to the second divided by x to the second. Remember, that's the quotient rule. So you got to subtract the exponents and you get x to the 0. And we know by definition, x to the 0 equals 1. So if you wanted to, you can write times 1, but then you would have to simplify it, meaning 5 times 1, which is just 5. And now hopefully you see how I got the answer. 5x to the second times the quantity x minus 5. Every single problem is done the same exact way. It doesn't matter what I give you. All right? Let's really step it up now. We're going to factor 21x to the third minus 9x to the second plus 15x. So there are 3 terms here, okay? Now, I'm going to really write this one out because I want you to see how everything works, okay? So step 1, let's find the GCF for the coefficients, okay? So 21, well, that's going to be 3 times 7. And I'm going to write 7 all the way to the right. 9 is going to be 3 times 3. 15 is 3 times 5. Now remember, with the GCF, you are looking for overlap. And the only time you have anything that overlaps is in that very first column. So your GCF for the coefficients is only the number 3. Now, step 2, GCF for the variables. Well, let's look at them. You got x to the third, you got x to the second, and you got x to the first. That's your smallest. So your GCF, oh, that GCF looks horrible. So your GCF is going to be x to the first, or just the letter x. Okay? Now, here's the key. Remember, every single term has to have something in common. All right, all terms must contain something in common. So just because you see x's, don't necessarily assume, okay, that you're going to be factoring out an x. Every single term has to have at least one x in order for you to do that. So now, our GCF overall is nothing more than just 3x. Therefore, and I'm just going to rewrite the problem so it looks nice and clean. 21x to the third minus 9x to the second plus 15x. We know the GCF is going to be a 3x. So you're going to be factoring out a 3x. Now, if you haven't noticed by now, as soon as I determine what my GCF is, I write it out front. I always put parentheses right after it with this big space because I know I'm factoring out. And by factoring out, what you're really telling me is you're going to be dividing every single term by 3x. So let's do it one term at a time. 21, or actually, sorry, we're starting off with the first term. 21 divided by 3 is 7. X to the third divided by x is x to the second. You see a minus sign, copy it down. 9 divided by 3 is 3. X to the second divided by x to the first is x. You got a plus sign, copy it down. 15 divided by 3 is 5. And x divided by x is 1. So our problem, or the answer to our problem, is 3x times the quantity of 7x squared minus 3x plus 5. Okay? And I think that's a pretty difficult problem, but hopefully you're starting to see the flow here. Now, here's an example where it kind of contradicts the previous example. And what I mean by that is this. I'm gonna highlight what I'm talking about. Boy, I really hope you like my videos. I really do. So, you got to be careful. All terms must contain something in common. Let me show you something here. Here's an example. We're going to factor 5x to the second minus 25x plus 15. So once again, I don't know why I wrote the word factor. We're going to do the GCF for the coefficients. So when you look at them, you got 5, which is prime. You have 25. Give myself a little bit of space. 25 is 5 times 5, and then 15 is going to be 3 times 5. So we definitely have a GCF for the numbers of a 5. But notice number 2, which is the GCF for the variables. Now, in this case, there isn't one. Let me show you why. The first term has x's. That's a smiley face. The second term has x's. That's a smiley face. But this third term does not have any x's. And there's a frowny face. In other words, since this last term right here does not contain an x, you cannot factor out any x's. Every single term must have something in common. Okay? So be careful. That means the GCF for this problem is only a 5. So I'm going to just rewrite the problem real quick. We know we're factoring out a 5. So I'm going to divide each one of these terms by the number 5. And when I do that, I get 5x for the first term. I get minus, oops, sorry, not 5x for the first term. I'm sorry. Hopefully you're out there in internet land going, you made a mistake. We get x squared for the first term because the 5's reduce. That was my fault. Minus, for the middle term, you get 5x. And for the last term, you get positive 3. The easiest way to check yourself is distribute. 5 times x squared is 5x squared. 5 times negative 5x is negative 25x. And then 5 times positive 3 is going to be positive 15, which is the original problem. Okay? All right, I'm going to do one more. Okay, I'm going to do one more. No, actually, I'll do a couple more. I think these are good. This one is definitely going to be probably the most complicated one we've looked at, though, so far. Okay? All we need to do is just be careful. So we're going to factor 9xy to the second plus 6x squared y to the second plus 21y to the third. All right. So I realize this looks very complicated. However, you got the tools. You got the skills to pay the bills. In other words, that's what my dad would say when I was younger. Here's what we know. Step 1. Let's get the GCF of the numbers. Okay? So, let's see. 9 is going to be 3 times 3. 6 is 2 times 3. 21 is 3 times 7. Notice the only overlap that we have is right down the middle. So our GCF for the numbers are going to be 3. Part 2. GCF for the variables. Now, remember, every term has to contain at least one of the variables. I'm going to highlight for us. There's an x. Here's 2 of them, but that last term does not have an x. So, what I'm going to do, is I'm going to write down no x's. Now, let's look at the letter y. I'm going to write down a letter y because I can see it. You got y to the second, comma, y to the second, comma, y to the third. Remember, the smallest exponent tells you that's your GCF. So our GCF for the variables is just y to the second. Therefore, the overall GCF is going to be 3 times y to the second. All right? Don't force it. Stick to the game plan. All right? So all I'm going to do now is just erase. I'm sorry, not erase. I'm going to rewrite my problem. And now I know my GCF is going to be 3y to the second. So the only thing I need to do is just divide every single term by my GCF, which is 3y to the second. So let's take it one step at a time. For the first term, 9 divided by 3 is 3. The x doesn't reduce. Y to the second divided by y to the second is 1. Plus, middle term now. 6 divided by 3 is 2. Nothing reduces that x to the second, so it comes along for the ride. Y to the second divided by y to the second is 1. Now for the third term, put a plus. 21 divided by 3 is 7. Y to the third divided by y to the second is y to the first. And there's the answer to your problem. Okay? Now, for the next couple examples here, there is something that I need you to be aware of. Once again, this is a math pet peeve. We always like our first term inside the parentheses to be positive. Okay? So what I mean by that is this. Here's an example here. Notice that we're going to factor, let me write out the directions. I do have a bad problem with writing out directions. All right, so we're going to factor negative 8y minus 40. Okay? Now, if you can see this very first term, it's negative. We don't like that. So what we're going to do is we're going to factor out not only a GCF, but we're also going to make that GCF negative. So if you come over to the right, 8, remember, is 2 times 2 times 2. 40 is going to be 2 times 2 times 2 times 5. So my GCF is going to be, well, if you drop all these down. Remember, we are concerned with overlap only. So the GCF is going to be 8. Now, here's the catch. We don't want that first term inside our parentheses to be negative. So, in reality, our GCF is going to be negative 8. Okay? Now, if you've been kind of catching on to what we've been doing, hopefully this is easy. We're going to write the GCF out front. And as soon as you've established that the GCF is negative 8, you're going to be dividing everything by negative 8. So, let's take it one step at a time. First term. Negative 8 divided by negative 8 is positive 1. Why? Now, in the second term, notice you got a double negative back to back. Let me draw a red arrow. You got that double negative back to back. Well, another way to just think about this is negative 40 divided by negative 8. A negative divided by a negative is a positive. 40 divided by 8 is 5. And that's how we factor out a negative number. That is going to be very crucial for us. Anytime you see a negative for that very first term, just factor out a negative, okay? Just factor out a negative. Let me show you another one here. All right, so I'm going to kind of speed up a little bit here, okay? Our GCF, let's see if you can figure this out on your own. But I'm going to tell you what the GCF here is. It's going to be negative 4b. So, I write negative 4b, put parentheses, and remember my goal is to divide each term by that GCF. So a negative 4 divided by negative 4 is positive 1. B to the second divided by B is B. Now for this second term, let me put an arrow. For the second term, you got to be careful. It's positive 16 divided by negative 4, which is negative 4. And then B divided by B is 1. So your answer is negative 4B times the quantity B minus 4. Okay? So that's going to be the first part of the class is over with. Here's the second part. Factor by grouping. And to be honest with you, this is very simple. You just got to be able to see things. So I think the easiest thing to do first, let's start off with a very simple problem. So we're going to factor xy plus y. So notice here, step 1, the GCF for the coefficients. GCF for the coefficients, there isn't one. How do you know that? Well, that's a 1 and that's a 1. You factor out a 1, nothing changes. So the GCF for the coefficients, there isn't one. What about the GCF for the variables? Well, in this situation, it'd be great if I could spell variable. In this situation, both terms have a y in common, and it's both y to the first. So my GCF for the variables is just going to be a y. Now here's what you would do. You would write a y out front. Then you would say, well, I'm going to divide both of these by y, and you would get x plus 1 as a final answer. Well, if you can see that, then you're going to be able to see factor by grouping, okay? So I'm going to start us off with a problem that's a little easier than the factor by grouping one, but here's what I want to show you. Forgot to write the directions again. There we go. Factor. Okay. So here's our problem. We want to factor x times the quantity y plus 6 minus 3 times the quantity y plus 6. Okay? Now, I know our gut instinct is to go ahead and distribute that x and distribute the negative 3 to get rid of the parentheses. But I'm going to tell you to stop. You don't want to do that. Remember, our goal is to factor something out. We want to pull something in front. And if you notice, here we have the quantity y plus 6. And here we have a quantity y plus 6. Okay? Notice both of those quantities are the exact same thing. Therefore, our GCF is a little bit more complicated than the previous problems, but the GCF is going to be y plus 6. Now, if you're telling me that's what the GCF is, here's what you're really saying. You're telling me y plus 6 is out front of a big set of parentheses, and you're going to be dividing both quantities by y plus 6. And notice, for the very first term, you have a y plus 6 in the numerator and a y plus 6 in the denominator. They reduce. They turn into a 1. So what's left over is an x. Now, in the second, you have a y plus 6 in the numerator, y plus 6 in the denominator. That turns out to be negative 3. So at the end of the day, and I'm just going to write it nice and neat, our answer is going to be the quantity y plus 6 times the quantity x minus 3. Okay? So now, let's apply this to an actual problem, okay? So I forgot to write the directions again. I'm always forgetting to do that. So we want to factor x times y plus 8y plus 3x plus 24. Now, in red, here's a big star. Factor by grouping will always start with 4 terms. Always. So if you look at the problem, like right now, I'm just looking at this problem right here, xy plus 8y plus 3x plus 24, and I notice 1, 2, 3, 4 terms. I'm already thinking, oh, I got to factor by grouping. Like that's what this is all about, recognizing what you're given. So since I have 4 terms, I'm going to write this down as steps. Step 1. Let's go ahead and group the first 2 terms. I'll put first set and second set of terms. Do not group the middle sign. All right, so here's what I mean. I'm going to group the first set. I'm going to group the second set. And notice that middle sign, I did not group. Okay? So that's step 1. Step 2. You're not going to find this in a book. But it's my own little step. I call it the mini GCF. So we're going to factor the mini GCF. And what I mean by that is this. Notice in the first set of parentheses, you got a y in common. So there's our mini GCF. So I'm going to write that. Y times the quantity x plus 8. Now for the second set of parentheses, notice you got a 3 and a 24. So you could definitely factor out a 3. So that's going to give you x plus 8. Now here's the most beautiful thing about using factor by grouping. It's going to be in green. Oh boy. There we go. Actually, it's in blue. Self-check. The binomial in parentheses should always match. Always. Now, you may be asking yourself, what in the world is he talking about? Look right here. X plus 8 and x plus 8. If you get the same thing in both sets of parentheses, you're doing it right. And that's an awesome thing. You actually have a self-check built into this method. So now that we've established that they're the same, we can actually factor them out. That's our GCF. So I put x plus 8 out front, and then what's ever left over, in this case, it's highlighted in yellow, will go in your second set of parentheses. And that is how you factor out, or that is how you factor using grouping. So I'm going to do 2 examples, and then I'm going to do one more where we got to be careful, and that's going to be it for this video. All right, so here we go. Here's another example. I'm just going to speed up a little bit. So we're going to factor xy plus 3y plus 2x plus 6. First thing I notice, 4 terms. So I'm thinking factor by grouping. Now you should have the steps in front of you. So I'm just going to call out the steps and you can read them. Step 1, let's group the first set of terms. Step 2, we group the second set of terms, and you rewrite that middle sign. That middle sign you never ever group. Now, step 2, mini GCF. So for the first set of parentheses, that mini GCF is going to be the letter Y. And you're left over with x plus 3. Now, if we're doing this correct, the next set of parentheses has to be x plus 3. Well, let's see. Mini GCF for the second set of parentheses, well, I can only factor out a 2. That's it. But when you do that, look what you get. You get 2x plus 3. Notice my binomials match, which is exactly what should happen. So I'm going to pull that binomial out front. And what's ever left over, in this case it's a y plus 2, is going to go in my second set of parentheses. All right? Now, for this last example here, this is where we need to be careful, okay? We need to be careful with this one. And would you do me a favor and just put down your pencils for a second and just watch? Because I'm warning you, I'm going to make a deliberate mistake here, okay? I'm going to make a mistake. So please, just watch, and then I'll show you, and then I'll fix my mistake. So here we go. Factor. We got 4 terms. Factor by grouping. So I'm going to approach this using my steps. I'm not going to worry about anything. So I grouped the first set of terms. I grouped the second set of terms. I copied on that middle sign. Now, mini GCF. For the first set of parentheses, it's going to be an X. I'm left over with X plus 3. And the second set of parentheses, it's going to be a 2 again. And I get X minus 3. Now, that built-in self-check should kick in right now. And notice, these are different. And there's the mistake that I made. They're different. So, what we need to be careful about, and I'm going to highlight it for us. What we really need to be careful about, is that middle sign right there. This is the number one mistake students make. If that middle sign is negative, you must change the last sign. You must flip it, whatever it is. So watch what I do here, okay? So hopefully you're just watching and not writing, all right? So here we go. Factor by grouping, starting over again, understanding that that middle sign is negative. I group the first set. I group the second set. But since this middle sign is a negative, this second sign has to change. So now I make it positive. And the reason for this is if I were to distribute this negative sign, I have to get the original problem. A negative times 2x is going to be negative 2x. And then a negative times a positive 6 is a negative 6. So you got to be extremely, sorry about that. You got to be extremely careful with this. If that middle sign is negative, the second sign has to change. I'm going to write a little bit more. When you group. So now that we know that, watch what happens now. Mini GCF, I can factor out an X. Mini GCF, I can factor out a 2. And now notice the insides of the binomials match, X plus 3. So I factor that out. And then what's ever left over, in this case, it's going to be X minus 2. Goes in the second set of parentheses, and that's it. And that's going to be it for this video. So good luck. I think the first section is the hardest because it's a brand new technique. But then as we start progressing, everything gets a little bit easier. I'm going to upload a factoring flowchart, and it's really going to help you to organize your thoughts with all this. So I'll see you in the next video. Bye.